All right, so multiplication of polynomials. This topic is actually kind of related to the grade 11 functions playlist that I have for students. And multiplication is actually kind of nice because at some point, both in grade 9 and grade 10, you should have run into the distributive property. And when you're just multiplying, now if it's just functions in general that are polynomials, then the distributive property basically plays the right role that we want. Now, in this particular case, I'm going to just do it through a few examples. And so this first example right here is, so I have two kind of functions and both are polynomials, as you can see. So one is of order 2 because it's x squared. The other one is of order 3 because it's x cubed. And now if you want to be able to multiply these and you want to be able to distribute, so let's kind of do that and remind ourselves on how to do this. And if you take the first factor, I guess, that we have in here, so this factor right there, now, and you want to multiply it by the second factor, so these are your f and your g that we have. Well, the only thing that we really do is we basically do a walkthrough and we multiply each term within the factor. So let's say this is my first term. So what we're going to do is we're going to take this term and we're going to be multiplying it by every single term in that second factor, right? So we're going to multiply it by all of these. And to do that, well, you're basically just using the distributive property. So you're going to be just going through and multiplying it along. So coefficient times the coefficient, and then we're going to be using our exponent rules to just add up our exponents, okay, for this case. So 3 times, really just there's a -1, okay, right there. So that's going to be -3, and now our x, so notice 1 is to the 2, 1 is to the 3, so that's going to be x to the 5, okay, because we're going to be adding them up together. So that's the first one. Then the second one, so it's 3 times 3, which is going to be 9, and then x squared and x squared. So that's going to be x to the 4, so that's that. And then the last one, which is 3 times the 4, which is 12. Now notice the subtraction, the negative there. So it's going to be -12, and then it's going to be x squared, okay, because the 4 doesn't have any x factors at all. So that's going to be the first thing. And now the second thing that we do is, so once we're done with our first term, well, then all we do is we just move over to our second one. So we're going to take this one and do exactly the same thing. Now maybe I'll switch colors. So we're going to do exactly the same thing. Now, what would have happened if you had more terms in this particular polynomial? You know, if you had 3 terms, 4 terms, then you would just do a walkthrough every single one. Now, of course, it would get a little bit annoying, but that distribution is relatively simple to do. So now in the second one, so we're going to get minus, so this is going to be 2x cubed, then we have plus 6x squared, and then minus just the 8. Now finally, once you do that, you can of course collect your like terms. Now in this case, our like terms, I'm going to just kind of scan through and then see if I have any like terms at all within here. So it looks like, well, we do have an x, I guess, squared here. Let me change the color so you can see it a little bit better. Okay, so we have this one is x squared, and I guess this one's x squared. So really those are the only like terms that we have in here, because everything else, the exponent on the x is different. So if I rewrite this in full, we're going to have, so those ones are the first two. Then I'm going to keep my minus 2x cubed from here. So I'm just going in order. So 5, 4, 3, and now -12 plus that. So that's going to be -6 now in total, and then -8. And that's pretty much all that we can do within here. So we kind of just leave it, and we have taken both of the two polynomials and we've multiplied them. So that should be kind of a déjà vu of the distributive property. Let's take a look at some other, few examples just to kind of complete this video, and again to give you a refresher of this multiplication of polynomials. So here's another example. So this particular example is a little bit simpler. Okay, so we have 2, so this is 1, and basically just a monomial, okay, because it just has one term. And then this is a binomial, which has 2 terms. So we're going to go one by one. So we have 14x cubed, and then plus, that's going to be 16x squared. So that's there. And that is all that we can possibly do with this one, because you know, these ones are not full out polynomials. There aren't any other terms that we have in that first factor. So that's pretty much it. I can't really collect these. They're not like terms, so you're done. So that's the first example. Here's the second example, which is a little bit more complicated, kind of along the lines as we had with the previous one. So I'm going to go ahead, so take this one, distribute it across every single term in that second factor. So we're going to have 2, that's going to be x to the 4. Then we're going to have minus, and this is going to be x cubed. Then we're going to have plus x squared, then minus x. All right, so that's the first one. So that's done. Now we're going to do it with this. So 1, 2, 3, and 4. That's what we have there. So now that's going to be minus 6x cubed plus, now it's going to be 3x squared minus 3x, and then finally plus 3. Now, any like terms, so we're going to try to grab these all together. So there's only one x4 that I see here, so I'm going to leave that there. So 2x to the 4, any cubed ones, so 1 and 2 here, so that's going to be minus 7x cubed. Then we have x squareds, that's going to be 4x squared. And then minus x, and that, minus 4x. And then finally plus, I guess, 3. And there we have it, okay? So we had multiplied the polynomials together and expanded the whole thing out and then collected like terms. So that's another example. Here's a final example. This one's a little brutal, but sometimes if, you know, your teachers maybe are mean to you, maybe they're kind of like me, you know, what if they give you, you know, not just, so here's 1 factor, 2 factors, 3 factors, and now you have multiplications here in between for these, you know, so what do you do in these cases? I typically go kind of from left to right. So, you know, I'll start first and I'll worry about these two. So I will multiply these together, you know, get my result. And then once I have my result, I'll collect my like terms and then I'll distribute it across times, you know, all of this. So let's try to do that so that you can see it and you don't, you know, feel like it's something beyond you in any way. All right, so the 2x, so we're going to have 2 and then x cubed minus, and then it's going to be 6x. So that's the first one. So this is what I'm doing. So I went this times that, and then this times that. So that's the first thing that I'll do. Now my second thing that I'll try to do is I'll multiply that. So that's going to be plus x squared and then minus 3. And notice that this is your first, all right, big factor that you've now created. And you can check, all right, are there any like terms within here? So it actually doesn't look like it, right? Because we have an x cubed, and then we have an x, and then x squared. So I'm going to just leave it as it is. I'm going to rearrange them. I like to always kind of put them in the order that they have. So meaning x cubed, so now squared, okay, and so on. So I kind of do it in decreasing order of the exponent. Now we have to take this entire thing right here. And if you do that, now it's going to be a pain, right? Because of the fact that if you want to be able to do this, you're going to have a lot of terms that you're going to have to go and multiply by. So for instance, here's my first one, and now I have to multiply it by every single term here, right? I have to distribute that across. So if I do that, so I'm going to get, so this is going to be 6x cubed, that's times the first one, minus, now it's going to be 2x to the 5th, notice there. And then I'm going to have plus 2 to the x to the 4. All right, so that's my first one. And now I have to do this for every single one. So I'm going to now move over to this right here and do the same thing. So my second one, now I know that most likely I'm going to run out of space there. So I'm going to kind of put them underneath each other as I go through. And then as I do that, I'm going to collect my like terms later. So x squared times 3, so it's going to be 3x squared minus, that's going to be x to the 4 times that. And then finally plus x cubed. All right, so that's that. That's my second one. Now my next one, so now I'm going to work with this. So negative 6, so times that, which is going to be negative, I guess that's 18x. Then I'm going to multiply it by this. So I'm going to get plus 6x cubed. And then times this, that's going to be minus 6x squared. So there we have it. All right. And then the last one. So if I remove this, I have that now right there. And now let's try that. So minus 9, so that's times this, plus 3x squared, and then finally minus 3x. Boy, all right, so that's quite a lot of work, but you're just going to be distributing it across. So I mean, that's kind of probably as hard as you will have it. And now in terms of collecting like terms, you know, so I can just kind of see through here. All right, so here's x to the 5, so let's rewrite them. I'll kind of go in this different color here, so that's this one. Now let's cross it off so we don't, you know, count it again at some point. Now there's the next one is x4. All right, so that's, no, notice here and here, nowhere else. So it's plus 2 and minus, so that's going to be just plus x to the 4. So that's these two gone. Now to the 3, so we should have quite a few of those. 1, 2, 3. All right, so that's 6 plus 1, 7, plus 6 is 13. So that's going to be 13x cubed. So that's gone, that's gone, that's gone. So that's great. Now squared. All right, so here's a square, here's a square, and then here's a square. So we have 3 minus 6 is minus 3, and then plus 6. All right, so that one actually disappears on us. So that's one less. And then finally, so we have our x and our x. Both are negative there. So negative 18 minus 3. So minus 21x. That's gone. And then finally minus 9. So notice the simplified form is actually kind of nice, right? So it's not huge. So we have 1, 2, 3, 4, 5 terms within here. It's order 5 in this polynomial. So it's not that bad. All right. And that's pretty much it. Okay, so if you're going to be doing these multiplication of polynomials, you know, you should be able to comfortably utilize the distributive property, even if you are dealing with polynomial functions. All right, so that you can distribute them. Okay, so thanks for watching. We'll see you in the next video. Okay, cheers everybody.